take a look at radical function. For example, you have y equals to square root of x. Remember the domain of this function. When you have a quantity inside square root, that quantity cannot be negative. This x must be larger than or equal to 0. We can use point plotting and graph this function x and y. Y in this case is square root of x. We know that we have to start from 0 and go to the right-hand side. If x is equal to 0, square root of 0 is always 0. If x is equal to 1, square root of 1 is 1. I'm going to use some nice numbers. I'm going to plug in 4. Square root of 4 is 2. We'll continue this process. If x is 9, you have square root of 9, which is 3. So having these points can help you to graph this function. X-axis, y-axis, and this is, for example, at 1, you have 1, at 4, you have 2, at 0, you have 0. So you can graph this function. This is the behavior of your function. Well, you know how to shift this to the left, to the right, 1 unit up, 1 unit down, and so on. So if I change x and I define a new function, y equals square root of x plus 1, I expect to get shift 1 unit to the left. Again, be careful about the domain. Domain is very important. This quantity cannot be negative. X plus 1 must be larger than or equal to 0, or x must be larger than equals to negative 1. It means that you can start at negative 1. So take a look at it. I have x, I have square root of x plus 1. So in this case, if I plug in negative 1, I get square root of negative 1 plus 1, or square root of 0 or 0. So the x-intercept happens at negative 1. So we can plug in more values. Suppose I plug in 1. I get square root of 0 plus 1, or square root of 1, or 1. For example, let's plug in 3. If I plug in 3, I get square root of 3 plus 1, or square root of 4, or 2. Let's try to graph this line. Square root of x plus 1. I changed my x value. So I expect to see shift 1 unit to the left. At negative 1, I have a 0. At 0, I have 1. At 3, I have 2. So this is the behavior of this function. This is square root of x plus 1. And this guy is, as we saw, square root of just x. You can shift it to the left and also right. So y can be written as square root of x minus 1. Be careful about the domain. When you have a function, the two important things about that function is the graph of that function and the domain of the function. Those are important. The quantity inside the radical must be positive. It can be 0 as well. X minus 1 must be larger than or equal to 0, or x can take on values starting at 1, then 2, then 3, and the rest of the numbers in the middle as well. So let's try to graph this guy. X and square root of x minus 1. If x is equal to 1, I'm not allowed to plug in 0. 0 is not acceptable. It must start at 1. So 1, you get square root of 1 minus 1, or square root of 0 or 0. Well, what if I plug in, for example, 5? Square root of 5 minus 1 gives me square root of, let's see, 4, which is 2. Okay, I know the behavior of this function, so I'm going to just use these so we can have more transformations as well. I have 1 and 0. Then I have 5, 1, 2, 3, 4, 5, and 2. So this is going to be the behavior of this function, square root of x minus 1. There we go. Again, as you remember, we can shift this up and down by adding and subtracting values. Now we're going to make some new changes. New change. In this new change, I am going to multiply my x by a negative sign. Y is equal to square root of minus x. See what happens here, guys. So y is equal to square root of minus x. I know this quantity must be positive, so the domain minus x must be larger than or equal to 0. So if I multiply both sides by negative sign, x becomes less than or negative, less than or equal to 0, all negative numbers and 0. This is the domain of this function. Take a look at the point plotting steps. X and square root of minus x. I know it takes values like 0 and some negative numbers. If I plug in 0, I get square root of negative 0, which is square root of 0 or 0. Now, I'm going to plug in, for example, negative 1 here. I have a negative sign inside the radical. Negative 1 becomes positive 1 or 1. I'm going to try another number, like negative 4. I have square root of negative 4 or square root of 4 or 2 back. Well, let's see what happens here. 0 and 0, negative 1 and 1. So I'm going to graph this right down here so you have a better understanding of the behavior of this function. 1 and 1, 0 and 0, 2, 3, 4, 4 and 2. So this is my square root of x. And now at 0, I have 0. At negative 1, I have 1. At negative 4, I have 2. Negative 2, negative 3, negative 4, I have 2 here. So if I connect these dots together, this is the behavior of square root of minus x. So I have square root of x on one side, and now I have reflection with respect to y-axis. So if I multiply my x by a negative sign, I get a reflection with respect to y-axis. My vertical line is y-axis. Now I expect you to ask, what if this negative sign was outside the radical? Another new change for you. If y was minus square root of x, I multiply my function by a negative sign. What happens then? For domain, we look at the quantity inside the radical. This guy must be larger than or equal to 0. So I still have to plug in positive numbers. So x and minus square root of x. If x is 0, I have negative square root of 0 or negative 0 or 0. If I plug in 1, I have minus the square root of 1 or minus 1. Take a look. If I plug in 4, I have minus the square root of 4 or negative 2. Take a look at this. See what is happening here. 0 and 0, 1 and negative 1. 1 and negative 1. This point is here. 4 and negative 2. Wow. Now I have a reflection with respect to x-axis. This is minus the square root of x. So reflection with respect to x-axis. If I multiply my x by negative sign, I get the reflection with respect to vertical line. If I multiply your y by negative sign, your positive y values become negative. So you have a reflection with respect to x axis. These are the new changes, reflect.